This is our first lesson on circles and their relationships. We're going to get into it by reviewing a little bit of old vocabulary that's going to be used quite often as we continue with our new lessons on circles. The first piece of our review vocabulary is radius. Radius is always represented by a little lowercase r. It's a line segment from the center of a circle to its edge. So this line right here would be the radius. You can draw a radius in many different ways. I can draw a radius going in any direction as long as it starts at the center of the circle and ends at the edge of the circle. Now the diameter, which is always represented by a lowercase d, a small d, a line segment that passes through the center of a circle and touches it twice. So this is what a diameter would look like. It's also important to know that you can make radius and you can make a diameter by using each other to create the one that you want. A radius is found by taking the diameter and cutting it in half, and the diameter is found by doubling the radius. For example, if the radius on this circle was 6, the diameter would be 12. If the diameter on this circle was 16, then the radius would be 8. Here's our first major part of our first learning target on arcs. We're going to learn what these arcs are and how we name them. A minor arc of the circle is a portion of the circle. So if we were to take the circle and we were to place some points right here and right here, and we're to give them some names such as A and B. The piece of the circle between A and B, which I'll represent with this green highlighter, this is a minor arc. It is an arc that is less than 180 degrees. It is considered the smaller arc. We name an arc kind of like how we name a line segment. We write down the two letters that make up the distance between the 2 points, and then we put this arcing symbol above it. This says the arc of AB. Minor arcs always only use 2 letters. Major arcs are arcs that are greater than or equal to 180 degrees. So A to B is a minor arc. I can't say A to B going in the opposite direction is a major arc. So I can't say this right here is also called AB, because AB is just 2 letters, and that is how we name a minor arc. So to name a major arc, you need to have at least one other point somewhere along the other part of the circle. Let's call this point C. It is along the larger yellow highlighted arc of the circle. We name major arcs by using 3 letters. And we go in order as we travel around the circle. A, then C, and then I travel around to B. So we use 3 letters. Minor arcs are the shorter, less than 180. Major arcs are the greater than 180. Minor arcs use 2 letters. Major arcs always use 3 letters. It's easy to remember that a major arc is 3 letters because 3 letters means it's a bigger arc. So let's try to name a major arc and a minor arc from each of these examples. In the first example, we're wanting to look for a major arc. The major arc in this would be an arc that starts at J and travels around a distance that is much bigger than a 180 degree spin. I travel from J through E to F. So J, E, F, the arc symbol above it is the name of the major arc. I want to make a minor arc, so I'm going to travel a distance that is shorter than 180 degrees, going from T to W or W to T. TW is the minor arc. Let's find a minor arc in this. The shorter distance is not from A traveling over to B, but from A traveling to D. AD is the minor arc. And the major arc in our last example would not go from M to L. We need to travel a greater distance. So going from M around, passing through O, and ending in L. M-O-L. Now, notice that the order of these could be different. I could have F, E, J, and that would also be an acceptable name. WT is acceptable for our second example. DA is fine for our third, and LOM is also okay for our last example. For major arcs, it is important that you have the correct letter in the middle, but our letters that begin in the name can be either way. Let's draw an arc given some information. So what is the information telling us about this first set of arcs using A, B, and C? It's telling us that there is a major arc on this circle of ABC, and there's also a minor arc on the circle of AC. So let's place a minor arc with an A and a C relatively close to it, so that we know that the distance between it, the degrees between these 2 points, is going to be less than 180. If I travel the other direction away from C, let's place the B on the other side of the circle, guaranteeing that if I were to travel around the circle from A going towards B and then ending at C, I've gone more than 180 degrees around the circle. In our second example, we have a lot to keep track of. We have 2 minor arcs and 2 major arcs. Let's try to get these put together in the correct way. Let's first set up a set of minor arcs called XR and SR. Notice they both use R. So I'm going to first place the R and then keep a S and a X pretty close to that R. Now let's see if we can correctly put the T. TSX or XST. Traveling from X, I go to S, and then I end at T. But if I place T anywhere in this section of the circle, it won't be less than 180 degrees. So let's make sure I travel and place it maybe here. Now I know that if I were to travel from T around to S to X, I have gone more than 180 degrees. Let's also check to make sure that TRX is also working. T traveling around going through R before ending at X is also more than 180 degrees. This looks like a good example of our major and minor arcs. The second important piece of information that is new for you guys for circles is called the central angle. It's an angle with endpoints on the circle and its vertex at the center. So this angle, which I'm going to highlight, is my central angle. It has endpoints on the circle, which we will call R and T, and it has its vertex at the center of the circle, which we are going to call P. We name these the same way we have always named our angles. Now, we do have major and minor arcs that are connected to every central angle. On this example, we have a minor arc that travels from R to T, minor arc. So RT is our minor arc. Our major arc would be traveling the opposite direction around the circle. But I cannot name this RT. Why? Because RT is the way you name a minor arc. We need to add one more point on here, give it a letter, and now I can name our major arc. Our major arc would be named RT. ST. Let's try to name the central angle for each of these arcs. The arc in the first example is arc TMS. And what connects down to the center of the circle is SKT. So angle SKT is our central angle. What is the angle for arc PBN? PBN connects to the center of the circle at angle PQN. Angle PQN is our central angle. What's the central angle for arc FG? Travel that back down from those 2 points to the center of the circle, and I see the angle FPG. Let's try drawing our central angles and our arcs together in a way that makes sense given some information. What is the information given to us? Well, we are given a central angle and we are given a major arc because of the 3 letters. It's not 2 letters, it's 3 letters, it's a major arc. So let's make sure that we're putting the correct point at the center. Look at the center of the central angle. It says F. So I know that F is the center of my circle. I need to make sure that wherever I place G and H, that I can correctly place the E for a major arc. Let's put the E over here. Let's see if it works out. G, F, H looks like a good central angle. And let's check our arc. Our arc of G, E, H does look major. This looks good to me. In our second example, we're given another central angle as well as a minor arc and a major arc. So let's first place our correct center. Center of the circle is the center letter of our central angle name, which is M. We need to make sure around M we're also going to have an L and an N. There is going to be a minor arc of NP. So I can correctly place that as long as I place those points pretty close to each other, N and P. That's going to be minor, less than 180 degrees. And now I need to make sure I place a major arc that is bigger than 180 and it travels from L through R and then hits P. I think I'm going to put my L here, and let's see if I can travel around the circle going in a distance that is bigger than 180 degrees and get the P. There we go. So in between L and P going this direction, I want to put my R. Did it matter if I had to go right exactly here? No, I could have placed a little bit higher, a little bit lower. Let's check all our work. I have a central angle of LMN. That worked out. I have a minor arc of NP. That worked out. And I have a major arc of LRP. So everything seems to fit. So that finishes our new information on naming and drawing central angles, major arcs, and minor arcs. Don't forget to hit the submit button after you're done watching the video.